Hi everyone, Lauren Gates here. I'm the Director of Open Source at Sangoma Technologies. Another virtual welcome to everyone joining us for day 2 of the AstriCon 2024 virtual track. Right now, we have our 4th and final virtual presentation for AstriCon 2024. On deck, we have Lorenzo Mangani from QXIP and co-founder of the HOMER project. Let's turn things over to Lorenzo with his presentation titled HOMER 10, Open Source Telecom Observability. At the end, we'll have a Q&A, so please leave all your questions in the question field and we'll address them then. Over to you, Lorenzo.
Thank you so very much for your introduction, and very glad to be here with everyone today. So as you introduced, the subject of today's presentation is telecom observability and how we address it and what's our vision of telecom observability with our stack HOMER. But before we get there, just a brief introduction. My name is Lorenzo Mangani, and I'm the CEO and co-founder at QXIP or QXIP. We're also known as the HOMER guys because that's, of course, our primary and flagship project. Our headquarters are in Amsterdam, in the Netherlands, where I'm joining today, and we see ourselves as an R&D company. So our real objective is to develop amazing technology to solve problems, and then of course we encapsulate it in both open source and other means to sponsor open source. We serve quite a broad range of customers worldwide, many of which of course are attached to the open source stack that we produce. And not all of them are telecoms, because today, real-time communication is something that spans much broader than, a few years ago, where, the audience was mostly just exactly telecom operator exchanges and so on and so forth. Today, we have a lot of enterprises that use voice and RTC in general to power a variety of functions and products. So we also fall into that scope. And we're a remote company, no owners, and we stay true to our nature. And the secret recipe of what we do is that we love it. So we started about 15 years ago as voice engineers that wanted to make their life easier, and that's how HOMER was really born. Today, we mostly power two stacks. One is HOMER, now at version 10 that we're finalizing, which is mostly what we're going to be talking about today, and Heic Cloud, which is the hosted version that contains all of our magic and skills for those that don't want to maintain it directly. Under the hood, we actually run hundreds of projects and repositories, but the main ones, or the main flags, are exactly HOMER and Querying, which today will make part of everything that we're going to be discussing, and Heic, which again is the hosted solution. But HOMER and Querying really do all of the job here, and they are the power horses of the solution. HOMER, which hopefully many of you will be familiar with, is a stack entirely dedicated to the VoIP components. So we started again some 15 years ago implementing our HEP encapsulation protocols in pretty much every open source voice project that was a part of the scope. So of course it's in Asterisk, it's in OpenSIPs, it's in Kamaido, it's in RTP Engine, RTP Proxy, etc., etc. We'll see a better list later, but it basically empowers all of those components to monitor themselves. 15 years ago, it didn't make a lot of sense. You can just sniff packets, but today, where encryption becomes more and more a standard, having an internal method for those platforms to monitor themselves, to volunteer data that they want to share for observability out without breaking security and without hacking themselves, is extremely important. And that's what essentially HOMER does with all of its agents. On the other hand, we have the querying subsystem, which is part of HOMER that will be merged and they function as one, which takes care of everything else. And actually I have a slide for this. So the previous versions of HOMER were entirely dedicated just to the packets, and everything else was external. If you wanted to do statistics, you could attach these numbers to something else. If you wanted to do alerts, the same thing. If you wanted to do any integration, it was possible, but also confusing. When you have too many options, when you have too many routes, it's easy also to make odd decisions that you want to go back. So in this new version, it's all at once. It's everything, and it covers everything that we think the modern telecom requires in terms of observability, spanning from, of course, our specialty inside the packets, SIP, RTP, RTCP, analyzing the real, underlying protocols from an engineering perspective that, make things go around, but everything around it as well. So if it's true that today most of our systems run in containers, virtual machines, complex stacks, and whatever, they move around a lot, it's important to also synchronize what we monitor from the inside with the environment. Right? It was an issue happening when there was also a capacity bottleneck on the system that was running our voice application, or on network in front of it, or with anything connected. Right? All of those things need to come together. And this is why with HOMER 10, we go for this global telecom observability vision. So we want to bridge everything that was already possible and making it easier, of course. So, from the first stage was making it optional to open Wireshark to troubleshoot something, which we have achieved over the years. And to want to go one step above. We want our users to see everything, to be able to observe everything at once, and more importantly, to make sense of the combination of the telemetry that we can capture in an easy way. So everything that's voice comes in, everything that's not voice can be mixed. And of course, those of you that are, working on the insides know that correlation is the real game here. So correlating the data that we get off the network, from the systems, from the logs, from the metrics, or from our applications or web clients and whatever, is the real art that's behind it. So capturing packets is really just half of it. The rest is putting them together. And to do so, we needed one environment that was up to par. And this is hopefully what assembles here. As you can see, in this stack presentation, we have HOMER, of course, taking care of the stuff, the subsystem querying for logs, metrics, and traces, and we'll describe more. But this opens basically compatibility with just about any agent or industry standard agent, I'm going to say, on the market that uses standard protocols, from open telemetry down to more specific standards to ingest any type of logs, any type of metrics, and then be able to query them, of course. And the interface that we picked to do all of this is Grafana, unsurprisingly, probably to those that already work with observability, but this is the center of the world when it comes to mixing signals and creating, let's say, productive environments to analyze and work with data. So Grafana was already fantastic at, of course, doing everything that has to do with, charts, time series, and so on and so forth. What it was missing is something that could help us, the telecom people, visualize our flows, which, are a little boring when you put them in a table or in something that's not proper. So that's what we did. Essentially is extending Grafana to be able to display our traffic and plug it all together. What you get is something like this. So for all of the systems that were already covered previously by HEP, we can now extend the coverage to all of their logs, all of their metrics, and even the traces. So we can trace the actual applications running using a variety of methods, voluntary, so the developers can implement libraries and exporters within their code that make these things available, or passively using eBPF. So we can attach ourselves to running processes that manage packets and calls and whatever, and we can really this time find out where the problem is. So we're no longer going to see a failure and have to guess why or bounce it around. With this type of system, we can see exactly what happened. If it was a network issue that propagates into the application, that crashes the code, no matter what happens, with this full stack monitoring, we can see it. So I prepared a little example. So if we want to apply this to Asterisk, what do we do? What's the starting point? How do we, start plugging everything together so that we can, get our feet wet with this global observability? It's actually just 3 steps. The first step is, of course, to enable the baseline, which is the packets from our side. So monitoring SIP, RTCP, everything that the system is generating and exchanging with and to its clients is the baseline. And this is actually quite simple. So for the normal cases where let's say the Asterisk system is complex or just uses UDP, etc., we can use the built-in HEP agent and the RESHEP and RESHEP RTCP modules, which can be enabled, and these basically allow Asterisk to monitor itself towards HOMER. So the packets that will be used in monitoring are not sniffed, but they're sent by Asterisk itself. We can just enable the module, and it just needs really the address. So the capture address is the collector, the address of HOMER. We can optionally use a password if we want to do authentication, and then we give it a capture ID. The capture ID is important when we have 1, 10, 100 Asterisk instances. We want to tell them apart. So this is kind of like a diagnostic ID that we can use in monitoring observability to tell where it came from. If you don't want to use the built-in agent, or if you have a complex public network that requires you to get more sophisticated, you can use one of our agents. Amplify is the lightest and basically does the same job but passively. So it can sniff and correlate SIP and RTCP that an Asterisk instance is generating and exchanging, and send it to a HOMER collector or a HEP collector. In this case, you also get to use advanced features, so you can send it encrypted. There's a few ways to do failover, and it's a little more sophisticated being detached. Both can also be used at the same time, so you can use the built-in Asterisk HEP module and send packets through Amplify. So it can also be used as a proxy in case where, let's say, you have to send this data over a public network, and so you can have it just encrypted, just like we do with everything else. And that's step one. Is going to allow us to collect all of the SIP and RTCP statistics into HOMER. Step two, we're going to go at the Asterisk metrics. So Asterisk has a fantastic Prometheus module that's ready to be enabled, just like the HEP one. By enabling this, we're basically gonna publish, not push, just publish a metrics endpoint that contains a bunch of statistics that we're gonna look into just next. And those can be scraped, so they're ready to be picked up and stored in a time series database in a monitoring solution. In this case, it's still HOMER. So through a vector agent, we're gonna scrape these statistics. And because we have to scrape them, they're going to be served by the HTTP built-in server. So they kind of work in tandem. The HTTP server is going to serve the metrics that are produced by the Prometheus module. This is basically just a long, list of metrics and values and types that just basically get scraped at regular intervals. I think the default is 15 seconds, and ingested. They only exist in Asterisk for a short period of time, so they don't consume a lot of memory or a lot of resources because they're continuously rotated. And it's it's HOMER and querying that sniff them up and store them. Last part, we're going to enable file logging as well. So we want the logger to be as full as possible, as complete as possible. And here you can enable anything that you want that's part of your setup. Because also those logs will be pulled out. So we're not gonna use them directly on the systems. Again, let's imagine you have 100 instances. All of those will be collected in a central point, and they will be all searchable at once. To pull them out, we're gonna use vector in this example, but there's literally dozens of agents. So if within your organization you already have a telemetry and observability agent that you trust, chances are they can be used to do the job just fine, because our counterpart, our subsystem, actually speaks a variety of protocols. So agents tend to be compatible at least in 2 or 3 integrations with querying and HOMER in this type. So one is just to push the metrics, and the other one is to push the logs. So this one scrapes Prometheus, the Prometheus endpoint on Asterisk itself, and it forwards it to querying for collection and processing. The other one does the same, but with logs. And here, this example only has one, so it's really shrunk down just to be symbolic. But you can sniff hundreds of different files, different logs at once, and send them all to the collector. So this just takes care of one, but you could also do the syslog of the system or anything that comes from any other application that's relevant to your troubleshooting. And here it's all you can eat. So there is no real limit other than the one on the other side. So typically, it starts with too much, and then you tend to learn what logs, what metrics actually make sense in your business. And our suggestion is always to drop everything that's meaningless to save time and space and concentrate on what's important. When this is done, we get the full picture, basically. So we can go into Grafana, and we can see our voice traffic. So this time we don't need a custom UI. We don't need to switch to the HOMER UI at all. It's all done inside of Grafana. And from here, we can search through everything at once. So we can look at traffic as, just a bunch of packets or a mix of packets and logs, or just really anything that you're ingesting. We don't really make a difference, but we allow you to display it on the same plane. So you can see in this flow, we're displaying some SIP packets and then some logs that just came to be correlated or part of the same session. So it's a entirely new, different plane where we can see some statistics. You can see on the left the distribution of responses and methods and the protocol and so on and so forth. In between the flow that you can configure, any chart, any histogram that you want to build can be created. When we select something, we still have access to the full packet. So in this case, if I click one of those SIP messages, I still have it all. So I see some tags that belong to this packet, and then I see the actual packet itself, which has been captured and reassembled by one of our agents. So, it's already in an advanced state. And then I can just go and look for anything else. This time is more like a, full text search experience. So you can search for everything at once. So I can go into the logs. I can say, okay, if I'm anything that contains user equal phone, choose one of those sessions, use the built-in correlation, and I'm going from a log into, let's say, the SIP and global view. At the same time, of course, in different dashboards and whatever, we can look at every aspect of our systems. And when I say systems, I mean all of them. You can zoom into a specific instance, or you can look at all of your traffic at once. This is why we have those identifiers. And we can see what's going on. So how many, what's the distribution of all of our methods over time. We can look at the RTCP collected quality if we have it with Heic RTP as well. We can look at the Asterisk metrics at the same time. So the passively obtained metrics and the actively produced ones are on the same plane. So this is what Asterisk is basically producing. So we can see, the uptime of the systems, how many calls it handled, histograms of the activity over time, active channels, calls, endpoints, bridges, you name it. And this is customizable. So it comes with the defaults that actually are already in part of the Grafana integration, a generic one, and they can be customized. So you can take any of these and make it your own. The data behind is the same. So, you can make it as good as you want. And of course, it's the same for the logs. So everything that we're collecting from the systems that belong to Asterisk, it can be displayed here. So how many logs we have, how many warnings, errors, error percentage, and of course, the size. This is useful, of course, when we want to alert on things automatically. So if, we want the system to do half of the job, of course, we can lock alerts on certain patterns. So if the error percentage grows of 5% over, 30 minutes, I want to be alerted because something is going on. And then maybe that alert can trigger another query that says, okay, show me the changes in, the SIP methods over the same amount of time. So maybe you can see that, you have an incredible amount of 401s coming unexpected. You name it, things happen. So you have this nice overview. Of course, the channel overview, so you can actually see what's going on under the hood. And this is all stuff that we just extracted. All at once, all in the same place. You can jump between the logs, the metrics, the calls, the packets without having to switch context, which we think is really the winning factor and what makes, let's say, this telecom observability better. Alerts, we mentioned them before. So the system already comes with some presets. So the restart, reload, and a few other things that are related to the call counts, etc., are already published. So those are literally ready to use. The moment you plug the system, that already exist. You can use them as a starting point to create more. And those, of course, can deliver alerts in, I think, at least a couple dozen ways, calling APIs, sending an email, or using other systems, PagerDuty, things like that. Grafana has an incredible variety of integrations, or you can make your own, still open source. So it's still a playground where, if a method doesn't exist, we can build it and create it together. And yeah, this is just a recap of those metrics that we're building the dashboards above. And again, those are not calculated by HOMER. They're just scraped from as many instances as you have at once, and then aggregated for you so that you can see the big picture or zoom into one individual region, group of instances, you name it. All of this is already available. So if you are brave, of course, it's an open beta, so it still assumes that we have to, round a few rough edges and implement a few more use cases. Mostly examples, documentation, and so on the way. But if you want, you can use this right now. And we have customers, for instance, if you're going to watch in the live AstriCon, the presentation of Shlomi from Voice Center, they have it as part of their production system. So this is something that's already usable. You just have to be skilled, but it's accessible. So if you want, the Docker Compose or the manual installation already work, and they do all of the magic. You just have to basically wire in your systems. This mind works for anything. So this example was for Asterisk, but I can slide up back here. There you go. Anything that was compatible with HOMER falls into the puzzle. So you have Chameleon, OpenShips, RTP engines, RTP proxy, or other tools, ASON or so on and so forth that you want to use. They're all compatible. So the voice part remains exactly as it was. Let's say in the old versions, everything is backwards compatible. And for the rest, it's standard. So the beauty of querying and the subsystem is that it doesn't invent any new protocol. We just made it compatible with everything Grafana. So this system is compatible with Loki and LockQL, with Prometheus and PromQL, and with Tempo and Jaeger for the tracing, without integrating them. So it doesn't have any Loki or Prometheus underneath. We took almost 2.5 years to recreate exactly what we wanted on top of a columnar database and make sure that all of this data could be in the same place, because that's also part of our vision. Having 5, 6, 7 different systems to take care of this data creates liabilities, points of failure, and it makes it generally difficult, if not impossible, to correlate everything efficiently, right? So it makes our life super complex at the beginning, but also every time we add or change something, right? If there's 5 databases that you need to take care of and maintain, and they all have a slightly different, lifetime, life cycle, upgrade intervals, and whatever, things tend to get, unmanageable and obsolete. So here we're also trying to solve that problem. Everything is in one place, everything is at once, and it delivers basically all of those features. That's if you want to manage it. If you don't want to manage it, as I mentioned above, we run Heic Cloud, which is basically our all of our open source compatibility with our commercial stack. This is how we sponsor all of our open source without having to attach anything to it commercially. So the open source is pure. Heic Cloud is just a hosted version of everything we have, where you got a few more things on top. So it's more scalable. It offers a few more ready-to-use things, and it adds, let's say, the ability to cluster many zones easily, fast results. It gives you infinite capacity, of course, because we take care of the scaling, and of course the same level of analytics. The thing that HOMER doesn't is the media reports. So this solution is also able to analyze actual RTP with a special breed of agents without dumping anything. This is our experiment in a version of RTP analytics that doesn't invade privacy. So it's a system that actually doesn't look at all at the payload, and it's entirely driven by codec-based models. So we develop models and algorithms that basically can predict how the quality will be uniquely based on the RTP headers. So without recording the voice, without intercepting people, without creating huge pools of data that can be leaked with inside God knows what. So it's a fully lightweight and transparent way of determining the quality over time. That's of course available in this solution and eventually in the rest. And with this stuff, you can do a few things. So it's easy to plug it into like self troubleshooting customer portal type of integrations where you can serve the traffic. This you can do it of course with both, with HOMER or Heic Cloud either. To do enrichment, so you can take the data that these stacks can extract and then use it to enrich other data. For instance, if you have passive CDRs, you can take data from what you get from this passive system to enrich them, right? Or just reconcile them. You can create dashboards, alerts. You can even use these data sets to start training some models for AI to recognize patterns and whatever. You can specialize it to do fraud detection, 911 tracking, et cetera, and then of course you can build experiences on top of it. So it's an open model. So from Grafana or from any other integration on top of your own data, you can build an entirely new UI, integration, portal, you name it. One last thing that I just plugged last minute because I think it's super interesting. Until now, we talked only about, let's say, active methods, so getting the logs, using native features of a specific system or capturing packets. But the frontier, and where we're gonna be moving really, really fast this year, is eBPF. So we also have methods to basically extract all of the above, where it's metrics, logs, or even the packets themselves, completely passively from the systems using eBPF. And we already have an agent for this. Our co-founder and CTO, Alexander Dubovikov, has a more detailed presentation. Basically, the next stage is that we're going to be attaching to or hooking into the system through the kernel, and we're going to be able to extract everything we want. So a lot is coming on this front, and it's going to have to do with basically all of your systems. The point is making it easier and easier and easier, and always more passive, so that we can have the same method survive application updates, upgrades, maintenances, and whatever. So that's basically what makes our stack today. So whether you choose to manage it yourself and go full open source, which of course is our preferred way, join our forums, come work with us, decide what stack is right for you. It's a matter of features and also what you really need or what you want to develop yourself. I have a quick table here, which is just a very loose reference, but many things basically except the RTP analytics part can be done with everything. And if something doesn't exist in the open source stack, we love to extend it based on user input. So all you have to do is just basically jump on our repositories, download the application, join the metrics channel. It's whatever you need, and talk to us, because this is what we do and this is what we love. So if you have an observability problem, or if you maybe see an opportunity for this stack, to solve a challenge that you've been having, that's exactly what we're looking for. Use cases to validate, our technology, our ideas, and everything that comes with it. So those are the addresses. If you want to reach out or if you want to join us. One thing that I always like to say, since we're talking about open source, as you interact with this or any other project, make sure you support open source before you ask open source to support you. So this is anything but being good people and trying to look at the common benefit is usually a fantastic way to do it, and the one that we love. And with that said, that's our presentation. Thank you so much for listening, and I think we can jump into the Q&A phase. I wasn't looking at the chat, but perhaps there are questions piling up.
Very much, Lorenzo. Am I audible?
Yes.
Excellent. My microphone falls asleep when it doesn't get used for a while. Okay, yes, as I said at the beginning, any questions for Lorenzo, please type them into the questions field in the webinar interface, and we'll address those. And while we wait for people to add some questions, let me thank you once again, Lorenzo, for that great talk. I was particularly interested in the idea of getting RTP analytics and statistics with without invading privacy. That's something that I had, my knowledge, I've never heard those words uttered before, and that seems like something that could be particularly useful in this environment these days.
Absolutely. We are ourselves, not very pro mass recording, so we always try to produce, tools that don't imply that aspect, even underneath. So it's a new challenge, but one that we love taking.
We'll start with a question from Akat. I don't know if I got your name correct. I apologize if not. Great presentation. Is there any migration from HOMER 7 to HOMER 10 documentation will be available?
Yes, we're working on it. For the good news, everything that you have for HOMER 7 continues to work. So this is kind of like an upward extension. So it's fully backwards compatible. What changes is really the UI and the way you're gonna explore the data. So the final part of this is exactly moving basically everything that you could do with the HOMER UI inside of the Grafana experience. I think we are probably about at 80% of that effort. So yeah, if you migrate, you literally can just continue using all of the same inputs, all of the same, let's say, HEP ecosystem as before. And yeah, just a brand new UI, and then of course underneath the data change. Our suggestion is to use two systems in parallel for this exploration. So not to do a one-off migration, but to spin up a parallel instance, send a little bit of traffic there, do your own assessment before deciding if you want to jump forward.
Question from Omid. Thank you for the presentation. Great software. Is HOMER help to identify voice quality problems? Can it show metrics like MOS?
Yes. So 2 levels. So absolutely, if there's RTCP, we calculate a first layer. So an RTCP-based MOS is always available. Of course, coming from RTCP, so it's not 100% reliable. To calculate the reliable MOS, this is available in the Heic solution right now. So it's going to be a bit before I think it makes it fully into HOMER. So we have it. It works for Heic Cloud right now, and this is the part basically that's analyzing the real RTP packets, and it's able to produce a MOS in chunks. So we don't make one MOS per call, but we make a MOS for each direction of RTP every X many seconds that you can decide, every 5, every 30, depending on your type of traffic, if you have short or long duration calls. So we have it in the hosted solution right now.
Comment from Tim, excellent presentation. Thank you, Lorenzo.
Thank you.
So I think we'll terminate things there. Thank you very much, Lorenzo. Excellent presentation.
I just want to thank everyone for participating, and of course you guys for having me. It's been a pleasure. And again, for everybody, questions coming up later, we're open source in the software and also as people. So just jump into our community, open an issue, get in touch. We're always here.
Good stuff. Thanks, everyone. Thank you, Lorenzo. Bye all.
Thanks, everyone.
Thank you all.